Hello everyone, welcome back to hopefully the last part of the Shanghai Tower Grasshopper tutorial. Um, in this part what we would like to do is basically just finish up the last bit of the crown details. So in the last part I talked about three main things that we could still do. If I quickly rotate to a nice view before I start to draw, the first thing will be to starting from the easiest perhaps to the most difficult is we have the, well, that's a very thick pen. We have the inner I think platform that's slightly raised above the original circle that you see here. So we can do that. That's quite easy to do. The other things that we will do actually is the vertical, almost the horizontal, not vertical, sorry, the steel rods, I think, the steel structure that you have going on onto that's also relatively easy to do. And if I clear this up a little bit to draw the last part, there's still this piece right here that we can try to divide that into the panels to be consistent with the ones that we have in the groove in the V-strike. So that's going to be another interesting part that we can look at, especially since this shape is quite irregular, so that might prove some challenges in terms of how we're gonna make that work. Alright, so with that said, let's go on with making the raised platform and then continue on with the steel rods, hopefully ending up with this. And then if the video is not too long, which I do hope so, I would plan to give sort of like a recap, an overview of what we've done, what you can do with it, and maybe hopefully try some experimentations playing around with the parameters we've set in the beginning. Okay, so starting with the simplest race platform, in the last part we ended up with some parameters that we can use. If I zoom into the output here, we have crown ramp. That's definitely not it. We're gonna use it later. We're gonna use this at the last, and this is the one that we're gonna be needing. So what we can do is basically just copy that and make sure the line is hidden. We can actually hide this part now when we show this. Alright, the easy way to do it is we're just going to basically do a scale. We might want to do a area first to get the center point. Wait, what did I click? Oh, that's the mesh area. I see. Well, we don't want that, so we want to just plug these in here. Just the scale. Default, it goes to about half, so you can decide whether or not you want to have this control always at the half or not. Since this is not, I don't think this is going to be a global parameter. I'm just going to plug in the list. Actually, let's do a slider instead. We're going to say the inner platform is going to be 70% the width, so we're going to just call this scale. I thought I had caps lock. Scale raised platform, something like that. Something that makes sense, obviously. So raised platform, there we go. And now the other thing we can do is if we quickly switch to a side view, which this one, if I select it, or actually the point, you can see that we're actually selecting at the very bottom. So what we want to do is just raise this platform maybe up to this level standard. And we know we have a parameter for that, which is if you scroll back all the way to the beginning, we've actually made a parameter for that, and I think it's this one. So the 8 is the floor above that line, is these. So if I switch to another again, you can see that the 8 is above the line where it starts to crawl, or where the ramp starts. The 2 is that line minus 2 floors. And we're going to be using both numbers, I assume. So we're just going to Control C that. Remember, we made that in the beginning in order for us to quickly be able to Control Shift V, paste in place, and have that already hidden and pre-configured in the way that we want it to. So now that we have that, what we can do is just move it up in the Z-axis, and we're missing something already. We're missing the floor height. I believe I can copy that somewhere. This one? There we go. So we just copy that, or you can copy from the beginning too, but they come from the same thing, so we don't really need to do that. We're just going to make a quick multiplication. Floors times two floors times the height gives us the move that we need. So we're just going to quickly hide all this. Wait, I do need to show that, so that we have our platform raised to the point where we want it to. Now the only way to do now is just to give it a surface. You can also do extrude, give it a little bit of thickness. Now the thickness, depending on how much you want to give it, we can do, let's just say, we're working with millimeters. Okay, so we can just say a thickness varying from 300 mil to, I don't know, 1,000. I think that's maximum. And you do want to make sure it goes down or it goes up. It's up to you. At this point, I don't think we're going to be doing much with it, so it doesn't really matter what you. But I want to keep it up so that whenever I decide how many floors should go up, it will always be below the line. You know, a little bit easier to manage. I'm just going to leave this as is. So I don't think I'll be changing this too much. Now, there's one more thing we're missing. Is there is another platform, because now it's floating, so we can just quickly create some sort of like structure that sort of make sure that it's like floating, because I believe somewhere here, or is it inside, you have the mass damper, tuned mass damper, which is really cool. If you don't know what that is, I suggest you to Google that up. You might even find results of the Taiwan 101 mass damper, which is also very awesome. Very cool stuff. So with that said, we'll just quickly go ahead and I'm actually just gonna keep this, and I'm gonna say whatever is you have here, I'm just gonna apply another formula. I'm just gonna say I want you to be 90% of that 70% scale. So that should, if I go to the top quickly, should give you fairly, well, I think we can go lower. I think we can go 50%. You know what, I'm just gonna go 60%, something like that. I mean, 50, 60 in this point doesn't really matter that much anymore, but so doesn't really matter, up to you. It's just small things that I just plan to do, because it makes this playing, it makes the crown a little bit more complete rather than just having an empty hole, which it's obviously not. So with that said, we have this one, and we can just use the move that we made. Let me see. So we do that, and then we're going to take that one here. It's not going to be moving up, it's going to be moving that way. Now, this might actually revert my decision to make that into a minus x. So because if I don't minus x, I will have this. I will have the component not overlapping. But actually, I still prefer if it does. Can I get that back? If it does that, the only thing I need to do now is just to have this number minus that 1000. So I might just do that instead. So I'm just going to do subtract. I am going to subtract. Wait. It has to be here. So I'm just going to subtract u with the 1000. Oh, actually, I might. Yeah, I thought I'm going to subtract factors, but I obviously cannot. Well, actually, I can. Well, that's not going to mess with that first. We're just going to do this. It's only one component. So we just do this instead. And we have clearly that one without any overlapping. Oh, I should have shown that. There we go. So that's number one. If you find this too high, obviously you can modify the floor height or not. If you find that this is like way too much, you can even lower this if you want to. You can actually plug in a number between these two. We have to make sure that this one takes from here some sort of like offset number, if you like, so that you can still make it adjustment to it if you want to. But I think for now this one should be okay. So we're just going to leave it at that for this part, or at least the first one. And we're going to move on to the horizontal steel rods structures. All right. So moving on to the horizontal rods, horizontal steel rods, what we want to do is we want to be able to control how many steel rods we have, basically controlling the density of steel structure we're going to be having in here, because we can control the vertical ones that you see, but we would also like to control the horizontal one which we're going to make. And one easy way to make that is we're just going to take a data or point from the very top, but the bottom that goes to the very top, and then from that we can create a line, and then from that line we can create points which we will attach xy plane to it, and that xy plane is going to intersect with a lofted surface we've yet to make from these vertical lines that we have here. So I think we can first make the lofted surface first to give ourselves a visual while we make it, and we can already do that with these. So I'm just going to quickly grab this one and set this to hidden. I'm going to hide that one then. So from this one we can already make a loft like that, as simple as that. But we do need to fill this gap. So in order for us to plug that gap, we're gonna take this one, since we're gonna be using this in later on anyway, so I might as well do it now. So I'm just gonna plug that in. So there we go. Since this is a surface and I want actually a line, what I'm gonna do is I'm gonna B-wrap deconstruct this, that one, and I'm gonna sort it by length, so that I know that I'm always going to be selecting the longest edge, which is the inner edge, and it's by no coincidence that's also the edge that we want for sure. That's always going to be the longest. I'm going to quickly sort this length, synchronize it with that, and if I do a reverse item list, I should be able to select the longest item. So I'm going to quickly hide that. There we go. So now that we have that, we need to make the loft. And what we can do easy is we can just take this loft here, copy this. Whoa, there's a lot of typing over there. So it's gonna create that. And for this one, we're also gonna select the last item and then create a new loft from there. Do have to flatten the C because the data tree doesn't match anymore, so it doesn't loft. But if you flatten it, it will loft. And the last thing what we can do is, let me make these there like that. We're gonna just merge these together, or actually we'll skip the merge. We're just going straight to B-wrap join and flatten that too, because I don't want to have to worry about data tree from that. So now that one is flattened, we have our surface that we're going to be using to intersect. And now we just need to intersect in planes, and to get those, actually we can use this line. Since this line is already from the very extends from the bottom to the top, right? What we can do with this, we can actually come in here and do a divide curve. And what do we call the parameter that we use to say density of the steel? Is it this one? Not too sure. Don't think so. No, it's this one. Yeah, I do remember we introduced that a little bit later, because this one doesn't say much. What I'm going to do is going to copy this one actually. Control Shift. And then this one I'm going to say, instead of vertical, it's going to be horizontal. Apparently we got 80 there. So we can plug 80 in here. We got 80 points. Ooh, that's way too dense. We might have to lower that a little bit. 30, let's start with 30. Okay, and then we're going to apply some XY plane onto these points. Now, before we do that though, notice that it's got the very top and the very bottom point. Intersecting on those when they're already at the top is not going to give you any line. So we might want to call those off first. And one easy way to do that, what I always do, is actually using a double culling. So I'm just going to set the integer to 0. I'm going to reverse the first one in both ends. There we go. And then copy that and not reverse this in this end. And that should get rid of the first and the last point. And now we can plug in our plane, which we can then intersect with a B-rep, which I think it's this one. B-rep and plane intersect. So the B-rep is this one. Our plane. Wait, is this not a B-rep? Yeah, it is. What is it doing? Oh, the error came a little bit too early. I forgot. Okay, there we go. Now this looks like a nice waffle actually. And now what we can do is see how it intersects everywhere, and then it just follows up our ramp. And now we can do is play with the density of it, if you so wish. So I might set this to 20, I think. Yeah, I think the other ones, we might even decrease that because that's way too dense for my liking. But anyway, this is adjustable, so that's fine. So we can just hide that, and we have our lines, which is, I think it's also sorted. If I quickly simplify this, it's also sorted by level. So we have like 19, which is this minus 1, of course. Let's create this many points. So we have 19 of these, and they're also sorted by, well, they're not sorted, they're actually one item per branch. So okay, now we have the second part also done with the first part here, and we can finally move on to this part, which is a little bit tricky. So hope you can still bear with me here. So moving on to the difficult part, the last part, what we want to achieve is to have a panelization that is consistent with our previously defined groove panels, the V-stripe panels. So we will need two things in order to make those happen. The first one being that we need obviously the cut on the same floor, which I don't think that's going to be too difficult. But the difficult part comes in, we also have another floor here. When you try to remember our V-stripe panel, the width from floor to floor is different because as it goes up, it gets smaller. And we want to have similar thickness or width for the panels here. So for example, if the top one is going to be like this, the bottom one might be slightly larger, but it's not noticeable, right? It's exactly the same as this one. Here you will not notice that the panel actually differs from each other because they align perfectly, because the panel actually is not fully rectangular. It's actually a little bit of a trapezium form where the top edge is actually a little bit smaller. So we will do the same here, where we will actually get a nice curve that goes all the way down like this. Of course, this will have to be like this. So that's our aim, that's our goal. If we manage to achieve that, this will be consistent with every panels there on the V-stripe. So that's what we're gonna try to do. And so let me quickly clear this up. So first off, we need those horizontal plane. Actually, before we continue, I'm gonna turn off a couple of things so that we can focus on these panels. So these are not gonna be in here, so we don't want to get distracted. We don't need to see that. We do want that. We don't need that. And we can get rid of these two, so we can just focus on that one. Well, no, we don't need to see this one, do we? No, we don't. Okay, so refocus. There we go. Clean slate, where we can begin. So to start off, we would need the data that we can use, to make those lines. And I'm actually thinking about using the V-stripe line from here. So we can actually use this, but that's missing the bottom half. So we can actually use this combined with that. which can work. But what I actually want to do is look at, is there not the curve, because we have the V-strike curve at the beginning, because that will give us enough to start on. So I'm just going to quickly look at where they are. Well, I found it here, but I don't need the lofted surface, nor do I need these 2000 lines, duplicated lines. I actually want something like this, and this comes from here, and this is 127 items. That's exactly what we want. So what I'm going to do is quickly make a curve so I can copy this over. So I'm just going to output it here. I'm going to include it in a group quickly. Give it a name. I'm going to call this full V-strike curves. Quickly make a copy of it. Hidden line, disable that. I'm going to do Control X to cut it so that I can just Control Shift V to paste it here instead of dragging it all the way across my screen. So now that I have this data, what I want to do is to filter out only the top floors that I need, because I don't need the whole thing. And for that, I have data here because I have the floors below. Do I even have the floors above it? Seems not. So I'm just gonna quickly floors below. Can I find it here? Nope. All right. Doesn't matter. We'll just keep it from here, which is this one. So I'm just gonna Control C, copy it, Control Shift V, paste it, and I'm just gonna put it somewhere here. We can order it out, reorder it a little bit later. So to select top, or the amount of floors that we actually want, we can do is, first off, we need to combine these two. So the top 8, I believe this is 8, and combine it with the ones that are below, which is 2, which get a number. And with this number, what you can do, we can actually do let's see, a series, or actually we can split the list. Why not? We can split the full amount of V curve, right? From, well, actually no, that's not gonna work. I was actually on the first strike the first time. I'm just gonna quickly recreate that. I'm just gonna do this, and I'm gonna make a list item. What I want to do is select the 10 items from here. First, I'm gonna quickly flatten this because I know that I'm gonna be working with a list, and I want to select the top 10 items. So for that to happen, I'm just gonna make a panel for you to visualize what I'm trying to do. So I got here, default, it gives me 10 items, right? I do have to plug it in here. Well, 10, 10, it doesn't change much. But what I do is, if I plug this in here, I'm going to be selecting the bottom 10, right? So if I were to reverse this list, suddenly I'm selecting the top 10. If I quickly scroll, or actually switch to this view, you can see that it's precisely ends or starts from the item that we wanted. So that's good. One last thing we need to do is we need to reverse this list, because if we don't, item 1 is going to start at the top. Now, whether that's what you want or not, it has to do with how you've been building your script. So in order to keep it consistent, in order to keep the data in the order that you expect them to be, it's a good practice to either do it from left to right, right to left, or top to bottom, bottom to top. So I can actually now disable that. Now that I have my item, I can also delete that. So with this, what we can do is, we remember that we said that we want to keep the width of these panelization the same as the V-strike panels that is on the same floor. Well, that's easy to do. Since we have these lines, what we can do is we just explode this. We know these are polylines, so because we copied from polyline. Now you can see all these segments, so all you need to do is just pick one segment, and you can just pick that segment which is at the start. But a better thing to do would be to pick the segment that's in the middle, so that you can know, because we could use that segment to build up to build up our script basically. So we're just going to quickly do that. To select the middle part, what you're going to do is do a list item to here, and then we're going to plug that in here. We're not selecting index number 8, but we are selecting index number, the total number divided by 2, which is always going to be the middle one. So it's giving us that part. Actually, I want the other way, pure preference actually. So I'm just going to quickly put this into parentheses, and I'm going to do -1. And that should give me that middle part. So I'm just going to hide this quickly. Yeah. Okay. With this, I can actually do now an endpoint. And well, what I actually want to do is if I create a line for now, polyline, there we go. Oh wait, actually we don't need this line, we just want to have the plane, so we can actually just do an XY on, well, let's do it on the endpoint. It's that closer, we'll just disable that. Is this an XY plane? Yeah, it is, okay. Alright, now that we have the plane that we can use to intersect, what we can do now is start intersecting. So I'm gonna quickly get to the point on the other side. So I'm just gonna quickly go to intersect. I want to have a curve and a plane intersect, so I'm just gonna take that, and I'm gonna take the line, not that one, that one, because we filtered it out in our previous step. So we're just gonna quickly filter that, and that would, and if I were to visualize it, I'm just gonna quickly make it like so. You can see we have our points. Well, we're actually missing this one, to be honest. Let's see how we're gonna fix that, because we do want equal number of points. Well, we could extend this part a little bit in order to achieve that, but there means the fact that we're not getting that point means we're actually missing it. That probably has to do with that the curve is not, yes, it's slightly downwards. That's because to do with the way that's been created from an SDL line that we made in the previous step. That probably just points a little bit downwards, but that's okay. That is perfectly okay. We'll just have to make sure that we filter that out, and we can do that by using, let's just get these endpoints so that we have the endpoints of that curve. And from this part, we just need to get rid of the start and the end so it doesn't intersect that, and then we could come back in and put those 2 points in, if you know what I mean. So for that to happen, normally I would say use a double cull, so you can call that point off. Actually, I might not have to do that, because if I were to do a polyline first, so I did have to make that polyline first and flatten this. I'll just flatten this part, and if I do a endpoint from here, I can already have those two matching pairs. So the only thing I need to do now for this one is to just do a double culling in order to get rid of that. So I'm just gonna quickly, I mean, didn't I do this before? So yeah, I'm just gonna copy that one, just make it a lot easier. Looking from this, I might just flatten this whole thing instead of just flatten this one. So I'm just gonna quickly do that, because I do need this to be flattened. And now I have my point, so that I can attach this point here and get those points. And then now I'm gonna quickly merge them back together, and I'm gonna use entwine for this, because I want to make sure that whatever's at the start point stays at the start, and merge can sometimes mess up your ordering. While this one, they just get hard coded into a branch, and then I can flatten that branch, which gives me the exact ordering that I need. So I'm gonna start with first, which is at the bottom, and ending up with the whatever's in the middle and the end point. So I'm just going to flatten this. There we go. And if I do the same for this one, yeah, that goes here, and the endpoint goes there. There we go. So now we have two of these sets where they can actually connect. And to check that I'm actually getting the right, so index number 1 starts at the bottom. Okay, so that's cool. And now we can make our line from here. Well, actually, I want to start from this side, so I'm just going to do that as A, and B goes there. So that's the line that we need in order to make this happen. Now you could argue that why not just intersect the B rep? That will give you the exact same line. True, that will give you a line, but it won't give you a line that starts here, and that's what we want. Because remember that we talked about we wanting that that whatever division comes, right? It's consistent. Because if you start suddenly here, what you'll get is probably going to be this, and I don't know how this will turn up. It won't mismatch at a certain point because the starting point is just shifted for that part. And for now, it's only 2 floors, which could be negligible, but it can well as be 3 floors or more, depending on how you set the parameters later on. But that's the way. That's why we're doing this. We're making everything as algorithmic, as parametric as possible, in order to accommodate whatever variables or whatever parameters we later on change. So that's the reason why I do it this way. It's a little bit lengthy, but it's robust. Okay. All right. Now that we have this line, we can start by getting the information that we have. Do we have the information actually? Yeah, the information we still need to find out is the width of every free strike panel because they get smaller as they go up. So I'm just going to quickly run through here and get a curve length. I might have to flatten this, to be honest. I'll just flatten it here then. Alright, I'm just going to quickly drag that here, and now I can say divide, not the curve, divide the curve by length. Divide length, there we go. I'm going to divide that length by these values. And there we have it. Now, a few things are going to happen. You will see that some of these, because we're dividing by length, if the length is shorter than, well, what the point can be, obviously they're not going to see any point. But we do need the endpoint. So to get the endpoints, we already have them. We just need to merge them to the right place. Now, if I quickly turn this on, you see that this line is actually built from these 2 points, right? The start and the end. Well, the point that we need happens to be just right there. Okay, so we just need to make sure that they go to the correct tree. I'm just going to quickly do a, let's see, a list item to confirm this item. Why is it so hard to find? Oh, there we go. Alright, so it starts from this side, obviously. And just quickly check that out because this now has to go really right in order for us to make it work. Don't worry about the wrapping, that's because wrapping is turned on here. So if I do false, you will not see it. So you can see that it goes from that way to that way. Okay, that's really good. Have a look at our data tree. I believe it's going to be very nice. Well, almost. I'm just going to quickly, because this is now flattened and I don't want it to flatten, I'm just going to graph it real quick because I do need it to be on their own branch. Well, the branching looks fine, but I'm not really a fan of the extra 0 in the beginning, so I'm just going to simplify that, and I'm also going to simplify this, and now they match perfectly. Well, at least that's my hope. So now I can actually bring in the merge. I'm going to merge this one to the U. Gonna have a look at how these items are now sorted. They still begin there, so that's fine. So I'm just going to quickly do 2 and turn off the wrapping. Okay, so 2 is the last one, and I suspect that we're going to turn error orange because that's the last one for the top. If I do 3, yeah, it's going to give me errors out of bounds, but that's fine. So now you can see that it will always include the very last one wherever possible. All right, now we can actually start drawing our vertical lines. The approach I want to do is we have these groups of points, and they should be aligned with each other vertically, or more or less, to create a nice consistent line. Um, what if we take a group that excludes the top, take the second group that excludes the bottom, and then have those two join together with a line? That should give us nice results, so we'll try that. Since we're dealing with trees, we have to use this split tree, and for that we need this tree stat, and then also the split tree. So we're going to split those data, and we're going to have the stat real quick, and we're going to do a list item. We're going to first get rid of the first branch. I'm just going to quickly hide that and create a point from the negative so I can see the negative. So this group excludes the bottom, so it's at the top basically. So we're going to copy that, move that up, and copy it from here. And for the second one, we're just going to reverse the path so that we are selecting everything at the bottom except for the top. Everything except the top one. So now that we have these two groups, before we do something else, I want to show you something first. If we plug in the param viewer, you'll see that the items don't match because 0, for example, here has 9 branches, whilst the other one has 10. So there's a discrepancy, and the data tree also needs to be corrected if I look at this way. So first what we want to do is make sure that the numbers match with each other, and there's an easy way to do that. Let me quickly scroll to list. No, where is it? Set here, list, longest list. So what these items will do is it's now default set to repeat the last. Is whichever list has fewer items than the last, the list that has the fewer item will just automatically get its last item duplicated. Right? For example, I know this one has 9 items, so if I quickly do this instead, like this, and I put in this one, now here you see that everyone gets 10 and everyone gets the same amount of items because this list has the longest, and I'm setting it repeat as last, so whatever's missing in this list will just, its last item will be duplicated. Okay, so now we can make the vertical lines like this. So now you might think, all right, we have our vertical lines, we have our horizontal lines, so why not just do a surface split? You know, obviously we need some work for that. Oh, not this one. And then you will have your splitted surfaces in there in each separate panel. Well, there's a problem. The surface split, to my experience, is quite unreliable because sometimes you would expect it to split a certain surface and then it would not split because whatever reason there is. And it often takes more time to find out what that reason actually is than just to find a more solid, concrete way, a more robust way that you know for sure is going to work. And on top of that, surface split usually is quite heavy in the sense that if you accidentally put a lot of curves splitting a lot of surfaces, or just one surface splitting a lot of curves, or any way around of the combination, you're going to have a bad time. You're going to have to wait a while for your script to load, and any changes you make will also be added up to that time. So you can try yourself to use surface split if you're familiar with it, but we're going to try a different method. What we're going to try is actually very simple in the sense that we're just going to loft, because we have these lines already, we're just going to loft them together to form the surface, and then we're going to find a way to just fix this part, the bottom part. Alright, so just to start, we're going to let's bring in a param viewer to visualize what we're doing. So we have these within their respective branches, so that's fine. Actually, I'm just gonna do a small shift list. Or better yet, actually, I can just call the item instead of shifting list. So first off, we're gonna call index number 0. So I'm just going to call off the first item so we don't see the line. And then the other one, we're going to call off the other way around. So we're going to reverse this. Make sure the double reverses so that the order stays the same, but then you're just removing that very last item. So now let me see the tree structure. I mean, it still looks okay, I would say. Okay. And now we have to make sure that each line is within their own tree, so that when we merge them, we'll get a branch with only 2 items. Because if we don't do that, when we merge it right now, what you will see is we have, well, that's not going to be a nice result for our love. So we're going to just quickly, actually I'm going to do it on this end. We're going to simplify it first. And then we're going to graph this, so that we have a nice branch where each of them is actually just 2 items. So then now we can bring in our loft and just loft this. Let me turn everything off. Turn everything off so you can see clearly what's going on. Even that one. Wait, no, let's turn that off in order to see what we have to do with it. All right. So now, you see, this is so fast. I don't even see how long it takes, because there's a certain threshold when a component is taking that longer, it will show it, which I don't believe we have in any of this. Versus if you were to do a surface split, you'll definitely see something down there, a few milliseconds, might be a few percentage of the whole script. But so this one is a lot safer, and it gives you exact result what you expect, and well, it's just a lot more robust. The only thing we need to do now is actually to find out how we can sort of filter out the bottom part. But that's relatively easy to do, since we have the line already. So once we have the data, I'm thinking about splitting it, well, a different kind of split, not the service kind of split, to achieve that part for us. Okay, let's start by separating this, because the top one it's fine, we're done with the top part. So let's start separating that, and we can do that by tree split. Sorry, eating my words. But we do need to find out how we can actually. I think we might have to trim the tree. So let's simplify it. So simplify doesn't work, because we want to trim this back down to their independent level per branch. So by doing this, we achieve the same results back. And with this way, what we can do is do tree stat like that, and we can just split tree split or split tree. Okay. And now we need to find out. Now we just need to do the same trick, but instead of selecting just only one item, we need to select the many item that is corresponding to the amount of floors that is below there. So we're going to quickly do a series, and I have the parameter here. I thought we have it. Oh, hit this one. So we can take that, drag it all the way here, plug it into the C, which is the amount of items that we want. So we want 2 items. We plug that in here. We get the 2 branches. So that we can use that as a masking to mask that out. There we go. So first off, let's pull out the negative. So the negative is the one that is already okay. So we're just going to hide everything. And we're going to also put one for the positive. So the positive is the one that we need to adjust. Basically, we need to fix. Let me fix my camera real quick. There we go. Okay. Since I mentioned that we have that curve, and I'm going to quickly go and find that curve. Let me see. We can have it from here. Yeah, from that one. I'm not sure if we used it before. Oh, this is that. I was wondering, why is that even stopped? Well, this is by length, but what I actually want, I'm just going to quickly create a branching out from here. What I want to do is, in order for me to select this part of the curve, there's a logic we can use, and that logic is, if you were to do a surface evaluate, okay, and why is it not here? Oh, surface evaluate. Oh, actually curve evaluate, sorry. And then you pick its middle, point, and then you sort it by height, because in almost every situation, this point is always going to be the bottom one. Okay, so we're going to just do that. We're going to do a deconstructor point. We're going to deconstruct that point, and then we're going to quickly sort this by its z value using that, and then we can hide all this. And now if we pull in a list item, we'll automatically always select the bottom curve. Now what I want to do with this bottom curve is this one we kind of can forget. What I want to do with this bottom curve, I want to use this curve to find out where they intersect. So I'm gonna quickly do a let's see, let's try pull to curve, as I might, because there's a, like for example, like these three panels, they don't touch the curve. In this case, they don't touch it. So whenever there is a point where they don't touch the curve, I don't want to process those. I don't want to process whatever panel is touching or is cutting this curve. So I'm just going to quickly do a pull to curve, because what this will give me is the curve that's pulled onto a surface. If it's not pulled to any surface, then it will just probably display a null. So I'm just going to quickly do C, and I'm going to do this, and I hope that I get some null values. Yeah, I do. These three are probably these four. Actually, those four are probably these, and then the other way around. Okay. Actually, now I can do a test for null in order to get the index out of it. True if item is null. Okay, actually, you can use that to dispatch it. So, for example, I'm gonna dispatch this using that. Now, what this will give me, if I quickly do another geometry node, I'm gonna drag these all down because I don't want it to mess with the ones above. I'm gonna hide that. I'm gonna hide this one too. You see that now we have the ones that are intersecting and the ones that are not intersecting selected. So now we can further process these by saying whatever is not cutting, we just not process it. We just take that as is. We still need to find a way to make sure that these four are not included. One actually easy way to do that is to make a just get a point on these, a center point, and then we can test whether the point falls within our main geometry, the backfold. And I believe there's a point include point in curves. I'm not sure where that is right now. I think it's here, analysis. It's a surface, because we are trying to say, does the point fall within a certain surface? Point in BRAP? Well, it's not BRAP. Pointing curve. Well, we can actually just use pointing curve by using the curve of the object from here. So let's see if that works. I don't know what C is. What's C? Oh, that's the region. Okay, that's good. And the points. So apparently it auto converts my surface into a closed polyline. So that's good. All right, and now I can actually, what's P projected point? Nope, I want the results. So it will say if it's 0 means it's inside, if it's 1 meaning it's coincident, it's on that edge, but it's never gonna be, and if it's 2 it's outside. So we can now quickly do a evaluate, and the evaluate command can say if x equals 0 then it's true, else is false. And then we can do a culling pattern to get rid of it. We might have to invert the true and false, but we'll see which one we need. So this is the one that we want to call, and just going to quickly get rid of that. And click over to the Y, plug this in here, plug that there. Yeah, we definitely need to invert this. So I'm just going to quickly change my expression, because false means yes, delete it. I mean, true means yes, delete it. False means no, don't delete it. Well, we actually want the other way around. You could actually just right click on the P and then invert, which is still doable. But yeah, either way works fine. All right, now that we have this one selected, we can actually get rid of that. Now we need to modify these in order to make sure the cut is the way we want it to. Now, one easy way to do that, we can just use let me get rid of that. Let's get rid of this. We can use the line that we have here and then use that line to cut through the object, and then where they meet, where they cut the point, we can use that to as a parameter to shatter our curve. So we'll just do that, and for that to work, we're gonna need a intersect, curve to curve intersect. I might have to graph this first because I want to make sure that every surface is on their own branch. We can, in the end, trim tree them back, so that's no problem. So I'm not gonna even convert this into edges curves. I'll leave that to the computer to do. I believe it can take that. It can recognize that. And the other ones obviously is gonna be our curve. But there's one problem in the sense that we are now connecting to 10 items, right? I mean 10 branches, one item per branch. So if you were just to take this and then connect them here, you're not going to see the result that you expect, which is a lot of points where they meet. So obviously we need to first make sure that this line actually is on this surface, and an easy way to do that is we can actually repull, right? Okay, we can repull the curve onto these new surfaces, and then we can, because now you can see every line is being pulled onto each surfaces individually, right? So that when we plug that in here, we won't have the issue of data mismatching, or even if a curve magically does not sit on the surface, so that it doesn't change, so that it doesn't cut. But with this, it does. Okay. And now we can do a shatter. For example, we're going to shatter that, and we're going to shatter based on the parameter on the T, which is TA, which is from that surface. So I quickly turn that off, and I'm quickly have a look. Turn this one also off on which one has been shattered. So we should have two, because it cuts the thing exactly in half. So because if you look at this, you can see that it's actually, well, that one is not selecting the way we want it to, I believe. So we might need to come back and see how we can fix that. But it pretty much cuts this in half, and it's the way we want it to. Now, to filter out the bottom part, there is a different way we have to approach. Instead of what you might think, we can just copy that and work with that. Well, I'm going to show you quickly why that doesn't work. Right? Okay, I'm going to leave this out for a bit. I'm just going to copy this one here and then put this one here. Now, the red arrow that you see right now, it says curve must be closed. All right, fine. We close it. And we do say connect to curve. Okay. We quickly graph this because we want them all into their own separate branch. And then we put this one here. And now the error that you get is curve must be planar. So meaning that these curves are not planar because they've been cut with the line here that apparently broke the planarity of the surface. Hence that this is not working, and why this one did work is because this was built from the same plane. We're not even using that curve to cut anything. And also remember that we had to use pull to curve in order to make sure that it connect here also. Otherwise they wouldn't see it. They wouldn't see it as an intersecting curve, because the curve is slightly on a different plane, or it's slightly angled, which is why we can't use this one. But luckily, let me turn this back off. But luckily, there's a way we can handle this. Since we have these curves, and we simplify the tree, that we can get a nice tree. So we put every half within their own branch. Okay. What we can do now is we explode these curves. which will give us a lot of these points. And what I want to do with this point is get the center or the average, and then you'll get 2 per panel. And in this case, obviously, the point that has the lowest z value is not the point that we want. So we'll just do that. And to get the middle point, another easy way, we just take an average, which usually takes a number, but you can also take a point. So if I take an average of that, you'll see that I have now 2 sort of like center points that's been averaging from the vertex that exist within each of these halves. So I can use that to say deconstruct deconstruct that. I might have to put these back. I actually don't even think I need to graph that. I'll have to quickly look at this. Oops. Not graph. Okay, I still do get those 2 points. So that's, well, now it's taking more points than I would like, to be honest. I'm not really want that. I mean, I expect to have 2, 4, 6, 10, 6, 10, 22, 20 points. Because, oh, okay, I have 5, 5. Okay, 20 points. And I do have that. So I might just be able to get this going. Do I have 20 points from here? I want to have this same structure at the end of this one, so that I can do a nice dispatch of some sort. So simplifying that obviously doesn't work, so I might have to do a trim tree. I think if I simplify this, what do I get? I get nothing, but I can simplify that just to make sure that the trim tree will trim one branch away, like that. So now I can deconstruct the point. Oh, I already did. Now I just need to do a sort, sorting these values, which is the height values, from the shattered curves. Is it the shattered curve? Yeah. Yeah. And if I say list item, give me the one that is the lowest, which is the one that we don't want, it will select all those. So I can now delete all that and do this. But if you want to select the other way around, just right click on the L and say reverse. And there we have it. And now we can actually come back here and say connect. Oh, actually not yet, because these are still not, they're not planar. So we need to make sure that they're planar. And one way we can do that is either we connect it now and connect it later, but we do need to project these points onto a plane that is going to be planar. So actually, you know what? Just to make sure it's complete, I'm gonna do this. So and now would be a good time to turn that off so you can see what we're doing. Okay, so now we have that one. This one is still not planar, as I will show you right now. I'll be damned if they are, because okay, see, they're not. What we want to do now is we're going to re-explode it. So everything we've done here, we just making sure that we got to this point, right? So now here we can sort of like start anew. We're going to re-explode this, or use this continuity wherever you want. Basically what I want is I want to have points, preferably more than 3, because now I can say plane fit point, or plane fit. And what this will do, it will create a plane for us that fits around a number of points that you have, and we can use this to create that plane. And now we need to move the plane. Actually, I don't even think I need to move this plane. I just need to say project onto plane, which project an object onto a plane, which is this one. So we can have this plane, and we're going to project, double checking the data tree structure. I'm going to simplify this so I get like 2 branches, because this one is also 2 branches, and then I can project that one. And now these should be planar. So now if we do that, it will give us everything. So I can hide all that, and I get my plane. And now last step is I need to recheck the data tree here. So I'm gonna re-simplify, even though it might be overkill, but I just want to make sure because I want to apply this. And before applying that, I want to make sure that why is my computer acting up? That they are on the being formatted into the right branch. Oh, that was weird. My panel looked weird. Huh. Okay. Don't know what happened there. So now we can combine them. So this, for example, if I do a merge, we combine this with this, and we should have a nice. If I do a tree branch select, for example, I might need to. I'm just gonna actually. I'll simplify that, and I'll simplify this. And then I'm gonna say 1. So 1 gives me all the top, and then the other one, obviously, the other floor. All right, that was quite a long journey for something as small as this. Well, I don't know what that was. All right, this is okay. I see. Let me drag this all the way. Actually, to make sure that the lines don't really go all the way, I'm just gonna quickly do this. And then drag this one instead all the way here. So now we can gather the stuff that we made and categorize or organize it. So we have this part. We need the upper part, which we turned off. Is it this one? Yeah, it is this one. Let me see. So the data is 0, 1. 0, 1. All right. We are actually missing 2, but that's okay. We can actually let me put a actually just put it at D4 and get rid of that one. Get rid of this one too, and I'm going to simplify that. Well, that's still. Oh, I graphed it in, so I simplified that. That was weird. Not flatten, no, just simplify. So that we have a tree. We're only missing tree branch number 2, but if you want, you can, of course, remake that, and that's quite simple to do. Where we can do a list length. Not sure at this point if it's even needed because we're actually done with this part. We're not going to be doing anything with this anymore. So on second thought, I might just leave it as B. But if you do want to make sure that you have your nice tree, if OCD kills you, and to have the 2 instead of the 9 here, then make sure they're all aligned. You can do a remapping, path remapper. This one, you might have to Google how that works out, or you can do a list length. Actually, you know what? I'm just gonna show you instead. This is what the tutorial is for. If you run into similar situation, you can apply it. But in this part, it's just for us. It's not needed. But I'm gonna still show you so you can apply this for your different project or your different objectives, what have you. So you can do this. So that way, will give you a item of every list, right? Actually, you can also do a tree stat, I believe. That one might even be better. I'm not sure. Tree stat, number of path. I don't know what this is. The length of each branch. Oh, right, yeah. So it's the same as list length. So you decide which one you want. Doesn't really that much. And so now what you can do is you do a partition. Okay, you flatten the incoming list, and you also flatten this one because you just want to have a single list of numbers. So now when you look at this, you have a nice renumbered. Of course, you can simplify this. You have a nice renumbered list of branches that starts from 0 all the way to the end with unbroken branches that you may have killed somewhere off. So that's one easy way you can do it. I might just keep that instead. Okay. All right. We have that, and we have now basically completed our last addition to our crown. So I'm just going to quickly do geometry, actually, to get these two all the way to here, like that. All right. I believe we have now everything that we want. So I'm just going to quickly, what is it called, inner structure. Well, it's still inner structure, so that's, might have to rename that. Right. We can call this inner structure part 2 or something like that. Oops, don't know what I did there. I'm just going to call this inner exceptions. Yeah, something like that. And then we can group this. Okay, I think this might be the longest video of every tutorial, but there has been a lot going on here, and you probably might want to come back here and basically whatever parameters you still want to make it global, like drag to the end to the all the way to the left side, so you can change. You can do that, and yeah, I hope you learned something from this part of the tutorial, because this is where I'm going to be ending here. And like I said in the beginning, I had hoped this to be the last part. Apparently, we spent too long doing the little things, but in the end, I do hope that you were able to learn something from that to be applicable, so you can apply to your own scripts and projects. I might rename this in off screen just to give them a sensible name, but that's where I ended here for this part of the tutorial. And as always, I hope you learned something new from this part, and I'll see you in the next one.